Hey, so today we are going to talk about exponential bases. It's going to be so much fun. So get ready. Okay. We want to break the numbers down into their smallest base. So in order to do that, we're going to create some factor trees. So this is how you do it. We're going to use 32 as our example, and I'm on page 105 in case you're in your book. Okay, so we've got 32. So we're going to think of two numbers that multiply to 32, and it can be any two numbers. So I'm going to pick 4 and 8. Well, there are numbers that can multiply to 4 and numbers that can multiply to 8. So I'm going to keep breaking these numbers down. 4 can be multiplied by 2 and 2. We want to go smaller numbers, not like 1 and something. And then 8 can be broken down into 2 and 4. And 4 can be broken down into 2 and 2. So basically, the number 32 is the same thing as 2 times 2 times 2 times 2 times 2. All the ends of this factor tree. It's a tree, and these guys are leaves. And this would be like the branch. It's upside down. So anyways, that's a factor tree. So 32 can also be written as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 twos. And then we can change this so that we're not just writing 2 5 times. We can use exponents because exponents are counters and they tell you how many. Well, we have 5 twos. So yay, we just broke the number down into its smallest base and we wrote it with a positive exponent. So now we need to remember, if we have a number in a numerator and a denominator, and I'm going to write it twice, if the number in the numerator has a negative exponent, then we need to move it down to get a positive exponent. If the number in the denominator has a negative exponent, we need to move it up to get a positive exponent, and vice versa. Okay, so here's what we have. Right now, this guy is technically a numerator. There's no fraction, so we can always put a 1 underneath him and make him a fraction. So he's in the numerator as a positive. It says in our directions that we're supposed to write our answers as both positive and negative exponents. So that's what we're going to do. We're going to change this guy to be a negative exponent. Now, we're not changing it to be a negative number. We're changing the position, the spot of the 2. So when we change the spot of the 2 to an opposite spot, then we have an opposite sign. So we're going to write that down. Opposite spot, opposite sign. Okay, opposite spot, opposite sign. And I'm talking about numerators and denominators. Okay, so this guy upstairs is nice and happy. So we're going to move this guy downstairs, which is going to be the same answer. And I'm going to show you in a second. When I move him to my opposite spot, then my sign becomes opposite. Opposite spot, opposite sign. So 1 over 2 to the negative 5th is the same as 2 to the 5th. And I'm going to prove it in my handy dandy calculator because I'm not sure you believe me. So we're going to prove it. Okay, so we're going to type 2 to the 5th in our calculator to start, because that was our first answer, and it should be 32, because that's what we broke 32 down into. We broke it down into 5 twos by making a factor tree. Okay, so now we're going to test this guy. So this says 1 over, and I'm going to use my fancy fraction button, 2 to the negative 5th power. And it's not a minus 5, it's a negative 5. Okay, so this looks just like I typed it. When I press enter, 32. So yay, it's equivalent. Okay, so these two are equivalent. You can say equal because they are equal, or you could say and. It doesn't matter. So let's do another one. So we're just going to do 343, and we're going to break this down into the smallest numbers. Since it ends with a 3, I'm going to see if I can divide by 3 to start, because I have to divide and figure out two numbers that multiply to get 343. So we're going to divide by 3 just to see if that works. Sometimes it doesn't. Oh no, that's not going to work. Okay, so now let's try another number. We're going to just try 2. 343 divided by 2. Oh man, we want whole numbers, so let's just keep going up. 343 divided by 5. Nope. 343 divided by 6. No, dang it. 343 divided by 7. Okay, great, it worked. So if you're not quite sure what numbers can go into your number, just keep guessing and checking. There's no problem with that. So 343 divided by 7 is 49, and I remember that 49 is a perfect square, and that is 7 and 7. Also, as a hint, all of the ends of your factor trees should be the same number. So if you got 7, it's probably going to be a 7 for the other ones. Okay, so these are the ends of my trees, my leaves, and that's what's going to be my base. So I know that 343 is the same thing as 7 times 7 times 7. And I can rewrite that as an exponent, and that's 7 to the third power because I have 3 7s, so exponents are counters. Now my next step is I want to rewrite this so I have a negative exponent. Since my base is currently on top of my fraction, I want to move him down. When I move him down, underneath my fraction, I moved him to an opposite spot, so I have an opposite sign by my 3. And these guys are equal. And there's my answer. Oh, that's a weird box. I'm so sorry. Okay, now sometimes we have fractions at the beginning. So we're going to start by making a factor tree for my 49 first. And we just did that. 49 has a perfect square of 7 and 7. Okay, so we're going to rewrite. And we're going to do the same steps even though we're in a fraction right now. It's going to be just fine. So we have 1 over 7 times 7. And you don't have to do this the more you get practice. I was just showing you where I'm getting my numbers from. And that's the same thing as 1 over 7 squared because I have 2 7s on the bottom. So we have a positive exponent on the bottom this time. So if we have a positive exponent on the bottom, when we move him up, we're going to have a negative exponent. So that's what's going to happen. He goes to an opposite spot. He has an opposite sign. So these guys are your answers. And it looks really weird to write a negative as an exponent, but you'll get used to it as you do it more. Okay, let's do one more just to make sure you've got this. We'll do number 9. So number 9 is 64. So we're going to just break this down. Well, I know that 8 times 8 is 64. And I know that if I keep going, because I want to go to my smallest base. So I want to keep breaking down my factor tree as small as I can. So 8 times 8 is 2 times 4, and 2 times 4, and 4 and 4 break up to 2 and 2, and 2 and 2. So it looks like my smallest base is 2. I've got 1, 2, 3, 4, 5, 6 2s. So let's just double check. That would be 6 2s, so 2 to the 6th power. I'm going to double check that in my calculator just to make sure I didn't miss any 2s because we drew so many, you know, maybe I missed something. So 2 to the 6th power. Oh yeah, that is 64. Okay, so we're doing great. And then also I want to rewrite this so we have a negative exponent. Right now he's currently sitting on top in the numerator spot. When I move him downstairs to the denominator spot, he's in an opposite spot, so he has an opposite sign. And these are my 2 answers. Okay, these problems underneath and for the second page, they work really well with factor trees, but they're telling you what number to take out of your factor tree. So, for example, number 12, see how I have a base of 3 over here, and I have an exponent that is unknown. So that means that 3 to some power is going to give me 81. Well, I'm just going to break this guy down, 81. So we're going to start by dividing 81 by 3. And the reason I picked 3 is because that's the base on the opposite side. So 81 divided by 3 is 27. And 27 divided by 3 is 9. And 9 is a perfect square, and 3 times 3 is 9. Okay, so if I'm looking at my leaves, all my leaves should match this guy. Even though we're going to talk about 11 in a second. But I've got 1, 2, 3, 4 leaves of 3. So instead of 81, 81 is the same thing. So we have 3 to the x. 81 is the same thing as all of my leaves multiplied together. 1, 2, 3, 4. Now my bases match, which is fantastic, but I need to change this side into an exponent. So I still have my 3 to the x. I have 4 3s, so it's going to be to the 4th power. Since my bases match, you ignore your bases and you look at the top. So x is 4. You can also think about it like if I know that there are 4 3's that make up 81, well then 4 should be 3 to the 4th power will give me 81. Okay, on number 11, so you can see how we broke down number 12 and we used our base that we had. On number 11, we're given the base of 4. So we have our 16, and we're going to divide by 4, and 16 divided by 4 is also 4. Now, you can break 4 down further, but we don't want to. And the reason we don't want to is because our base needs to match whatever we have in our problem. So if there's an exponent with an x, we need to make sure our leaves, our base match. So I have 2 leaves that are 4 from our 16. We don't want to go further. We don't want to break this down into 2, 2, 2, 2. We don't want those leaves. We want the 4's. So I have 4 to the x equals 4 times 4, and 4 times 4 is the same thing as 4 squared. So since my bases are 100% the same, they're both positive 4's, then I can look at my exponents, and x equals 2. Okay, let's do one more together. That might be a tiny bit longer, but still amazing. Okay, let's go to number 19. 19, 625. Okay, my base is 5, so I'm going to start by dividing by 5. So, here we are. 625 divided by 5 is 125. So we're going to put 125. And then again, you have to divide by 5 because I want all my leaves to match this number that's by my x on my exponent. 125 divided by 5 is 25. And I know that 25 is a perfect square and it's made up of 5 and 5. And if you don't know your perfect squares, then just keep dividing by 5. Look at my cute little leaves. They're all 5's and they're supposed to be. So on the left-hand side, I have 5 to the x, and then on the right-hand side, I want to change my 625 to have my base of 5. Since I have 1, 2, 3, 4 of them, I'm going to have an exponent of 4. Since my bases match 100%, they're both positive 5's, I'm going to look at just my exponents, and x equals 4. All right, if you have any more questions, talk to your teacher. Have a great day. Bye.